torque. The next topic is torque. Torque. Force and torque. Torque, madam. So which is denoted by the symbol tau. Right on the first point, the relation between torque, dipole and electric field. Torque, dipole and electric field. So tau is equals to Pe sin theta. Tau is equals to Pe sin theta. Right on the next topic, potential energy of a dipole. Potential energy of a dipole. Right on the first point, the relation between potential energy, dipole and electric field. U is equals to minus Pe cos theta. U is equals to minus Pe cos theta. The next subheading is special cases of dipole in uniform field. So uniform field in the sense, what you should get in mind is, whenever they are talking about field, electric field. Okay, so we'll I'll give a tabular column here. We can take the tabular column. Okay, draw the tabular column. The first case is when theta is equals to 0 degree, second case is theta is equals to 90 degree, and third case is theta is equals to 180 degree. So we were talking about the torque and the potential energy, no? So what was the formula? For torque, PE sin theta, for energy, PE cos theta. Okay. So by using this we can get the type of equilibrium also. If you remember this tabular column, it is easy to understand. Okay. So it is, let me take other color. So angle. Okay, what is the topic we are talking here? Torque, energy, special cases of dipole. So what is the meaning of dipole? Like two equal and opposite charge with same magnitude, right? No. So this is minus and this is plus, and 90 degree, no. So it is plus and this is minus, like initially it was the case. So electric field is passing. So angle is 0 degree. Now I have rotated to 90 degree. Now again I will rotate to the 180 degree. So 180 degree in the sense this is minus and this is plus. Okay. So torque will be, what is the torque formula, and if I substitute the angle, what I will get? 0. Take down. So torque is equals to 0, and in the second one torque will be equals to PE, and third case 180 degree, no, sine 1 minus 1 cos 180 only minus 1, no. So what about the energy? U will be equals to minus PE, and what about here? U will be equals to 0, and what about the third one? Okay, U will be equals to PE. Any doubt here? Any doubt here? We are substituting only the angles. So cos 0 is 1, cos 90 is 0, cos 180 is minus 1. So minus of minus, it will become plus, and here I am writing as it is, minus PE. Okay. So type of equilibrium. The first one is stable equilibrium. First one is stable equilibrium. Second one is, it is unpredictable. And the third one is unstable equilibrium. So why I have given this tabular column means, like in some questions they have mentioned only about what is stable and what is unstable. They have not given what is the angle. Okay. If they have given unstable, what is the angle I should take? 180 degree. If it is stable, 0 degree. Okay. We will do a question now. Write down the question. An electric dipole of a dipole moment P, electric dipole of a dipole moment P is placed in the position of stable equilibrium, in uniform electric field, of intensity E, capital E. Full stop. It is rotated. What happened? It is rotated through an angle to keep it in unstable equilibrium. I will repeat the question now. An electric dipole of a dipole moment P is placed in the position of stable equilibrium in uniform electric field of intensity E. It is rotated through an angle to keep in unstable equilibrium Okay, full stop. Then what is change in potential energy? Then what is change in potential energy? In this question, if you have noticed, they have not given the angle, they have not mentioned the angle here, they have mentioned only what is stable and what is unstable, right now, and they are asking about change in potential energy. Initially, how what is the potential energy? It is minus PE. Okay, initially it is minus PE, then it has been changed to PE. So what will be the change here? Change in potential energy will be nothing but U final minus U initial, no? Yes, no? So can I say like PE minus of minus PE is nothing but 2 times of PE. That's my answer. Okay, right on the next topic. Electric field lines. Electric field lines. The first point, electric field lines electric field lines of force are a visual representation of are a visual representation of I'll repeat the sentence. Electric field line of a force are visual representation of the electric field. Visual representation of electric field. Second point, it is a curve drawn in such a way that the tangent to it at each point is in the direction of net field. I guess you have remembered that morning I have told that if I draw the tangent for the given diagram will give the direction of the field, right? Right on the next point, a field line is purely a geometric representation, and which has no physical existence. So morning I have told two things for positive and negative. So for positive it is outward and for negative it is inward. Draw the diagram. no physical existence. It's purely imaginary. No. The next subheading is properties of electric field lines. The first point, electric field lines of force originates from positive charge and infinity and terminates at negative charge and infinity. See here in this, no, like you have doubts. When I talk about only positive charge, no, so it originates, no, so it is going out, right? So where it is going out, like it is going to infinity, right? If I talk about positive and negative, obviously like positive charge is going to negative charge, but when I talk about only negative charge, it is coming from infinity, yes, no, and terminating at negative charge. Understood the point? So when I talk about only like positive or only negative, originates as positive and terminates at infinity, which means at infinity negative charge is there. Here at infinity positive is there and terminating at negative charge. Second point, electric line of a force always represent the net electric field. Next point, the electric line of a force never intersect each other. Okay, so I have told you the reason in the morning why it never intersect each other. What is the reason? It has only one direction, no? If it is intersect each other, it will have a possible of more than two direction. So it has only one direction, that's why it never intersect each other. The next point, the number of line originating the number of line originating or terminating, originating or terminating is directly proportional to, is directly proportional to, is directly proportional to the magnitude of charge, the magnitude of charge. Okay, so this point is telling that if I talk about q charge and plus phi q charge, like plus q and plus phi q, so which is more? Plus phi q is more. So this charge will produce more number of electric field lines than the q charge. Okay, so the electric field lines is directly proportional to the magnitude of the charge. So which charge is having more magnitude, that charge will produce more electric field lines, and the intensity also will be more in the plus phi q. Okay, if you want you can take the diagram and we can go for the next point. Okay, so the next point is if electric field line, if electric field lines of force density, of force density, if electric field lines of force density is high at a point where the electric field lines are more, where the electric field lines are more and closer to each other, where the electric field lines are more and closer to each other, closer to each other. Okay, this is about the properties. So I will give a question here. Try to identify what is the charge present here. This is point P and this is point Q. So what is the charge of P and what is the charge of Q here? P is minus and Q is plus. Any doubts here? Okay, you can take down and we will go for the next one. Next question. Right on, next topic, equipotential surface. Equipotential surface. So like the name itself tells that like the potential is equal at the surface. Okay. So if I talk about three surfaces are there, this surface is having 5 and this surface is having 7. If I talk about the second surface at any point, it will be 5 only, because like I am talking about the equipotential surface. If I talk about any point, if I talk about this point or either this point, the point will be 7. That's third surface, no, I am talking. Okay, write on the first point. Equipotential surface means equipotential surface means the equal potential at or through equal potential throughout the surface, equal potential throughout the surface. Right on, next point, equipotential surface may be the surface of a body, or a surface in a space, For example, next point, for example, the surface of a charged conductor, is an equipotential surface, charged conductor is an equipotential surface. Okay, so this is the thing. And what is the relation between potential and electric field? Potential and electric field. Right on, malli paper తీసి చూస్తుంటారు కదా. E is equals to minus dV by dr. E is equals to minus dV by dr. Okay. Now they might ask you the theoretical part question. They have told that like at the conductor it is equipotential, right? No, if I talk about this is the conductor. Okay, so this is my surface, no, this is my surface. So the charges are in the surface, For example, you can take that there are 50 people in a room, so no one likes each other, which means everyone will go away from each other. Okay, so at center what it is there? At center, about conductor I am talking. Okay, I am talking about this room now. So 50 people, no one likes each other, everyone will go to the like walls. Okay, like each wall they will go and they will stay. And what is there in the center? Like empty space will be there, benches anta. Like empty space will be there, which means the electric field at center it will be 0. Okay, electric field at the center, it will be 0 for a conductor. Okay, you can take down, take the diagram. Okay, write down the next subheading. Equipotential surface of a point charge. Equipotential surface of a point charge. Of a point charge. Equipotential surface of a point charge. Okay, first point, field line is perpendicular to equipotential surface. Field line is perpendicular to equipotential surface. Line perpendicular to equipotential surface. Field line starts from high potential to low potential. Field line starts from high potential to low potential. Field line starts from high potential to low potential. So what is the meaning of this? So field lines will travel from high potential to low potential. Okay, starts from high to low in the sense starting from high and ending at low. Next point, charge in potential is directly proportional to field strength. Charge in potential is directly proportional to field strength. Okay, write down the next heading. Okay, last topic. Okay, I'll complete this and we'll wind up. Okay, relation between electric field intensity, and potential. Electric field intensity and potential. So the formula is E is equals to minus dV by dr. E is equals to minus dV by dr. Okay. Example number 1 or question number 1 under this. Question 1. V is equals to 5x square. V is equals to 5x square is the potential at a point. Then find the electric field. So can I get the electric field here by using the relation dV by dr? No. So here they have given V is equals to minus 5x square. No? In terms of x they have given. So can I write E is equals to minus dV by dx? Yes, no. So what is the differentiation of 5x square? I mean only 5x square is the okay. 5x square. So it will be minus d by dx of 5x square, which is nothing but minus 10x. That's my answer. Next question. Still two more type of questions are there, we will complete that. Okay. V is equals to, next question is V is equals to 7y plus 2. V is equals to 7y plus 2. So what is the electric field for this? Minus 7. So it is minus 7. So what you can understand through these two examples, whatever the values, the variable is given with respect to V, that variable I need to take with respect to differentiation. Okay, if they have given x, I need to take x. If they have given y, I need to take y. If any variable are there, with respect to that I need to differentiate it. Okay, now last example, find the potential difference, between A and B, of uniform field, So this question is not based on the differentiation. Okay. So this is my field, the angle made is 45 degree, so the point A is here, so which is nothing but 1, 1, and point B is somewhere here 5, 5. So I need to find the potential difference of these two. In terms of and like electric field lines is given as E naught, electric field lines is given as V naught, so E naught. Okay, I need to find the potential difference. Last two question was electric field. Okay, this question they are asking potential difference, which means can I say E is equals to minus dV by dr, right? No, here if they are talking about the points, no, I can take the minus delta V by delta R. We are not talking about at particular point, we are talking about the difference between them. Average velocity and instantaneous velocity we have came across. No, average means nothing but I will talk about the difference. Instantaneous means at that particular point. Okay, now we should do in terms of like average velocity. So what is dr, like delta R? Change in the distance or displacement, no, like the distance between them I need to find. So what is the distance between them? How to find this distance? Do it. See, so this is 1, 1 and this is 5, 5. This distance I need to find. 4 root 2. Yes. Itla sir. So what is the distance here? This one. This is 5, no? And this is 1, no? The difference between them is 4. And this is 1 and this is 5. Difference between them is 4. This is like sum of square of the two sides should be equals to hypotenuse square. So which is nothing but, let me take this as r. So r will be equals to under root of 4 square plus 4 square, which is nothing but 4 root 2. This is my answer for this. And now they are talking about the change in potential. So E naught will be equals to minus delta V by 4 root 2, which is equals to delta V minus E naught 4 times root 2. This is my answer. They have given the electric field as E naught. Okay. one question, homework question, you can do it. Okay, partial differentiation. V is equals to minus 5x square. V is equals to minus 5x square plus 3x plus 15z cube plus 15z cube. Okay, I will repeat the question. V is equals to minus 5x square plus 3y 5x square plus 3y plus 15z cube. Find the electric field. Find the electric field. Okay, I will tell you the hint here. When you are differentiating x, keep the other two terms as 0. When you are differentiating y, keep x and z as 0. When you are differentiating z, keep x and y as 0. Okay, I will repeat it. When you are differentiating x, okay, which means minus 5x square, no, keep y and z terms as 0 completely. Only differentiate x. Okay, keep it as, keep as it is. When you are going for the y term, keep x and z as 0. You will get the differentiation of y. So you got x and y. Now if you are going for z, no, keep x and y as 0. Then you will get z. Add everything. You will get the differentiation of the three terms. That is partial differentiation. Okay. Right. So this is the thing, and get the answer. We'll meet in the next class.